What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about different applications with normal distribution. So if we were to look at this problem right here, we can see that it says lifetime of light bulbs are approximately normally distributed with a mean of 57 hours and a standard deviation of 3.5 hours. That's no big deal. You guys can just draw the normal curve and put down 57 and add 3.5, add 3.5, add 3.5, subtract 3.5, subtract 3.5, and subtract 3.5, and you got this, right? And now if there was asking your, hey, what's the percentage of light bulbs that is going to last longer than 60.5 hours, you guys got it, right? You guys can just add those areas under the curve and voila, you got your result. However, what if we're not asking for these numbers here? What if we're asking for more than 60 hours, right? Where the 60 hours is not along any of these numbers right here. What do we do then? Well, that is where we got to normalize our data so that the mean is 0 and the standard deviation is 1. And so on and so forth, right? So that's what we have to do when we do this, is that we're going to have to normalize this so that it matches our mean of 0 and standard deviation of 1. So how do we go about doing that? Great question. So here, just so I can show you guys everything here. Yes, it's weird that I just kind of started in the middle and then kind of came forward from there, right? So to normalize it, what we're looking for is actually a z-score, right? And to find the z is x, the data point, minus your mean divided by standard deviation. That would normalize it. And in that case, then we can use our TI-84 or our Desmos to figure out what those probabilities are, okay? So it's a normal CDF, which is again second distribute, and then second vars, which would give me distribute, and the second choice is normal CDF. And on Desmos, it would be under functions, and I got to scroll down to distributions, and it's a normal distribution, okay? So what do we have to do? We got to be able to find the area to the left or area below the given z-score, the area to the right, which is above the z-score, and the area between two z-scores. All right. Now, the reason why this is here is because when you do function and hit normal distribution, this 0 and 1 is going to be blank. You're going to enter the 0 and the 1, which saying I'm going to go ahead and normalize this data so that my mean is 0 and my standard deviation is 1, because that's what it wants in the argument, is mean and standard deviation. And then you're going to check off this find the CDF. Again, normal CDF. And then it's going to have a minimum to the maximum. And notice it says negative infinity to positive infinity, which gives me the area on the curve as 1. Okay? Same thing as this normal curve right here. If I include everything from 0 to negative infinity to positive infinity, it's going to cover everything under the curve, which is a probability of 1. All right? So that part is important. So as we're looking at this, so getting back to this problem here, if I need to look for more than 60 hours, here's 60 hours. So I'm really looking for this area right here. Now, good news is that after you calculate it, you can actually figure out if this area seems correct or not. Because if you go in here, right, remember this was 34, this right here was 13.5, this was 2.35, and this was 0.15. So 0.15 plus 2.35 is 2.5, 2.5, and then plus 13.5 is what, 16? So it's going to be more than 16%. So if you get something less than 16% or something that's more than, 50%, then we know something is wrong, right? So this is a good indication of kind of drawing it out, draw your line, shade it, and go, okay, that's what I need to find. So let's see if it works. So let's see. Let's find the z-score of 60 hours. Okay. Okay. So to find that, what we have is this fraction, and we're going to use 60 minus the mean, which we found as 57, and the standard deviation was 3.5, which is what's given in this problem right here. Okay, 57, 3.5. All right, so when we put that into our calculator, where's my calculator? Let me grab that right now. Boom, boom, boom. Okay, so I have 60 minus 57 and divide that by 3.5. I get 0.8571 ... right? It keeps on going. So that's what I have, all right? So if you look at this, if I was to standardize this, right, to mean as standard deviation, the mean of 0 and a standard deviation 1, does 60, where 60 is located, is between 0 and 1, does that look like it would be about 0.8-ish, 0.8, 0.9-ish, right? It's very close to 60.5. So this location is between 0 and 1. So yeah, the 60 would be somewhere close to 0.8571. 71, right? Which is exactly what this is right here. It seems about right. So that's always a good indication that I did something right? If it was negative, that means I must be talking about somewhere over here, right? So this is a positive. Makes sense. Okay, so that's a good start right there, right? So from there, where do I go? So from here, this is where you're going to type it in as a normal CDF, which I have done right here. Let's bring this up. So here's what you would type in, a normal CDF. And notice that this area is going from this point here all the way to positive infinity, right? Forever and ever. That's what I want, okay? So that's where I would put down, here's my minimum, here's my maximum, and I'm calling 9,999 as positive infinity. You can put more 9s in there if you want to. You're welcome to do that, but it's going to give you the same result. At some point, it's going to kind of wash out. And the mean and the standard deviation. So again, I'm going to put in here that for the normal CDF, it's going to ask for your minimum, your maximum, and then 0, 1, which is your mean and standard deviation, okay? So, and we're using negative 9999 as your negative infinity and 9,999 as my positive infinity, okay? So that is what you're going to have to do with the TI, all right? So that's what I entered right here. So I'm going from here all the way to positive infinity. So there it is, to infinity. My mean and standard deviation is 0 and 1 because I normalized this so that this is actually mean of 0 and standard deviation of 1. Standard deviation 1. So in fact, let's do this. Let's move the 60 up here. I guess I should probably make these not red to be like 60, but maybe blue, and put parentheses around the 60 as 0.8571, right? So that way, at least we kind of know, yes, that seems right, all right? All right, so what does it look like on Desmos? Well, let's take a look. Let me Hopefully I'm not making anybody motion sickness by going up and down and up and down. All right, so with this, I already said that we would put in 0 and 1, right? Normal distribution. Check this CDF. The minimum is 0.8571, and it goes to infinity. And there we go, right? So that is the most important part. So there you go. And even notice the numbers are exactly the same. So, excuse me, my probability is going to be 1957. Or in that case, about 19.57%. Okay? Which makes sense, right? Because we already said that this is going to be more than 16, but way less than 50. So 19.57 seems about right. All right? Next one. It wants the proportion of the light bulbs that will last less than 52 hours. Well, here's my 52 hours. Right? And I want less than, so I'm going to shade less than. So less than is going to look something like this. Right? So that's what I want. So I'm going from negative infinity all the way to 52. Correct? So again, let me normalize this and see. So normalize it. So I want 0, 1, 2, 3. Negative 1, negative 2, negative 3. Okay, let's take a look. So it's going to be negative. It's going to be between 1 and 2. Somewhere in there, all right? So let's take a look. Let's see what that looks like. So the x is 52. My standard deviation was 57. And my my mean was 57. My standard deviation was 3.5. Okay, let's take a look at what that gives me. So I said 52, and that's going to give me a negative 1.4286. Yep. There we go. Does this look like about negative 1.4286? Absolutely. It's between negative 1 and negative 2 and somewhat close to the middle. Makes sense. Okay. So we're good right there. All right. So now, so again, this would be a z-score of that 52. Okay. All right. So with that said, let's go ahead and type this into our TI. Oops. So normal CDF from negative infinity all the way to this negative 1.48286. Mean of 0, standard deviation of 1. That's what I have here. Let's see what the Desmos tell me. Does it tell me the same thing? You bet. Right? So normal distribution from 0 to 1. CDF. Minimum of negative infinity all the way to negative 1.428. And that's what I get. So it is going to be 0.07. I guess I would put down 66. Okay. Which is really approximately 7.66%. So is that about 7.66%? Yeah, because this small little piece was 0.15. This is 2.35, so that's 5%. And then a little bit of this 13.5. So yeah, I that would make sense. All right. So what if it's between two things here? For some reason, my 57 disappeared here. So let me go ahead and duplicate this, bring this over here. Because 57 is right here. So I didn't need it. So there we go. All right. So I want from 57 to 61. So here's 57, here's 61. So I really want this area right here. There we go. All right. So I want that area right there. So I normalize this. This is actually 0. And 61 is so close on it, I can't even put down 1 there, but I know it's between 1 and 2. So let's normalize that 61, because normalizing 57 is easy, right? That's just 0 because that is the mean. So this is going to equal to my 61 minus the mean, which is 57, and the standard deviation is 3.5. And when I do that, I get a positive 1.1429. Okay. So then we can plug this into our TI-84 or Desmos. So where am I going from? I'm going from 0 to this 1.1429, right? That's where I'm going from and to. From 0 to this 1.1429, and mean and standard deviation, that's what I got. Let's take a look at, this would give me the same thing. And it does, except I didn't give this enough space. So let's go and move this down. Right? So same thing, from 0 to 1.1429, mean and standard deviation is 0 and 1. So this is going to be 0.3735 as my probability, which is about 37.35%. Is that about right? Well, within one standard deviation is already 34%, and I'm taking this little sliver right here. That would make sense that at least it's more than 34%. So at least that's what I got there. So that part does make sense. Okay, so here's the next question. What if the problem was asking, right? If I'm looking for 19%, right? So if the alpha is given as 0.17, that is two possibilities. One possibility is if it's 19% that is growing, that is lasting longer, or is it the 19% that's lasting less? Okay, so that's why I gotta figure out which tail do I want? Do I want the right tail or do I want the left tail, right? So that is gonna be very important. So in other words, this area here is 0.19. Well, this area here is also 0.19, right? So if I was to find it, I'm going to be able to get the z-score in that location. So if I was to do that, I would get this z-score, or I can get this z-score. Question is, which one do I want, right? So typically, it all depends on the question, right? So let's take a look at this. Let's find these two values, right? So I'm going to guess I need more room here. So I'm going to bring this down to the next page. So let's see what it will give. So you have to understand what your calculator gives when you're doing this. So in terms of the TI, it's very, very, very easy. So to show you guys what menu you need, what you would go is, again, second vars, which is distribution. The third choice here is inverse normal. InvNorm. Okay? InvNorm. So that is the feature that you guys need. So what does it ask for? Well, it asks for a couple of things. Oops. So when I just type it in straight, let me see here. When I type it in straight, this is what happens, okay? So notice what it's asking for. I'm looking for the alpha, and then again 0 and 1. Okay, so this is the percentage I give. So when I type it in just as alpha, comma 0, comma 1. Okay, when I do that, what it gives me is a negative 0.8779. So it's giving me this value right here, negative 0.8779. So in other words, on your calculator, most calculator does this. When you're putting this alpha in, it's giving you this less than percentage. That's why it puts it right here. So if you look at it, this is 0, this is 1. So this would be 0.87. Makes sense, right? In order for you to get this value here, if it wants more than, then what you have to do is change this alpha to something different. And let's show you what you got to do. So to find the red z-score, right? So this is going to be z is equal to, okay? So to find the other z-score, you would literally have to do this. I want you guys to notice this. This is going to be 1 minus that alpha, comma 0, comma 1. Okay? So notice that I had to put that 1 minus in there. Okay? When I put the 1 minus in there, what does that give me? That gives me positive 0.8779 as my z-score. Okay, so that is very different. So you got to be careful. Do I want the left tail or the right tail? Okay, just using alpha gives me the right tail. Using 1 minus alpha gives me the, oh sorry, I went nuts and forgot my left to my right. The alpha gives me left tail. The 1 minus alpha would give me the right tail. Yep, there we go. Okay, so that is the important part. From there, now you can look at what they want, right? Because if you notice, again, the 0.19 is this whole whole area here or this area here, right? So area itself is still the same. Let me go ahead and let me see. All right, so for the Desmos, however, a little bit different. And I'm wondering if I have enough space here to put this down. So let's do this. Let's go ahead and move this question. And actually, let's move this question. Oopsies, undo. Let's grab that whole question, bring it down here so that I can bring this here so you guys can see it. So for the Desmos, you got to do a couple of things. You have to name, give it a special name. Doesn't matter what it is. I'm just calling it capital N for normal, right? It's a normal distribution. It assumes that the mean, so I left this blank because it's going to assume that the mean and standard deviation is 0 and 1. I checked the frequency, the cumulative probability, which is a CDF. I call the minimum Z sub A, okay? Next part I put down is the inverse CDF of N, which is this N here, comma A, okay? So it asked me if I want a slide bar for A, so I have a slide bar right here that I can move this around, or I can just tap on here and erase this and type new numbers in there, okay? Now, my suggestion to you is that you want to write this, have the slide bar, and then also enter the 1 minus A, which is the 1 minus alpha, okay? So notice that, so even on the Desmos, it's also just the alpha gives you that left tail, while 1 minus alpha does give you the right tail. So if you notice, it gives you that, right? So now, if you look at the next question, it says 19% of the bulbs will last more than how many hours? So I want more than how many hours, meaning I want this to be my 19%, and I want more than how many hours. So I want to know, since I now have the z-score, I want to know if I unnormalize it, where would I be, right? So I know that z is equal to x minus mu divided by the standard deviation, correct? So what I have now is the z-score, which is my 0.8779, and that's going to equal to what I don't know, which is x, minus my mean, which was 57, divided by the 3.5, okay? And because that this is a single fraction, and this is a single fraction, I can actually cross multiply. So what I have is 3.5 times 0.8779, that's going to equal to x minus 57. So let's see what that equals to. 3.5 times 0.8779 is going to be 3.07265 is equal to x minus 57. So now I got to add 57, so x is going to equal to, so plus 57. So I'm going to be 60.07 hours. So again, I'm given the alpha, and now I want to know how many hours. So I am unnormalizing it to the regular language or regular lingo that you would actually understand based on the data that was given. All right. Well, I hope that helped. If there's any questions, please let me know. See ya. Bye.